Hi everyone, I am Nigesh from Team ClatPrep. I welcome you all to this series of Quant Magic. Now today we will be discussing yet another important and interesting concept of percentages, that is successive percentage change. Now first of all, what does the word successive mean? Successive means one after the other. So what happens when I change a number with a certain percentage one after the other? Let's take a look at it. Say suppose there is a number 100. I increase this number by 10% twice, that is 10% and then again 10%. Now first of all, think about it, that whether this overall change, is it equal to 20%? Because normally it feels like 10 plus 10 it should be equal to 20, but whether it is actually equal to 20, the answer is no, it is absolutely not. Why it is not equal to 20? Because when I increased 100 by 10%, the result was 110, and when I did the second change, I again increased by 10%. I did not increase 100 by 10%, I actually increased 110 by 10%, so the result will be 121. Now here, if we try to look at the overall change done in the original number, that was 100, we can see that the original change was 121 minus 100 by 100. This is a simple concept of percentage change, right? Final minus initial upon initial into 100, or you can say change done upon base into 100, and the result we get here is 21%, which is we can see not equal to 20%. Okay, now please take a note of this. Whenever you are increasing a number by a certain percent, and that too you are increasing successively, the overall percentage increase done in case of successive is always greater than the linear percentage increase. Now this very concept might help you, and it will definitely help you in the questions of compound interest, because therein we will be using successive percentage change and the multiplying factors quite a lot. Okay, now what happens when I reduce this number? Now this reducing of the number is a very common example. Okay, let's take a look at it. Let me take an example in front of you. Say suppose we went to shopping in a particular mall. Okay, I saw two brands, one was Flying Machine and the other one was let's suppose Pepe. Okay, and the Flying Machine, there was a poster put up there which says 20% plus 20% off. These things we see very commonly in our day-to-day life, right? Whenever we go to shopping in end of the season sale or whatever the particular sale is, we see such things written there: 10% or 10% plus 10% off, 20% plus 20% off. Now the first feeling which generally people get with this is we are getting more than 40. Or let me elaborate the example further. Say suppose there was this Flying Machine store which said 20% plus 20% off. Then there was another store, Pepe, which says flat 40% off. A lot of people get this feeling that 20% plus 20% means I'm getting more than 40. That is something extra. Let's look at what actually happens. Okay, so basically let's assume the number to be 100. What happens when I decrease this number by 20%? And that too twice, again successively, whether it is equal to 40 or more than 40, the answer is no, absolutely not. Why? Because when I reduced it for the first time by 20%, the result was 80, and then I did not reduce 100 by 20%, I reduced 80 by 20%, the result was 64. So if you will try to look at the overall percentage change done here, that will be 64 minus 100. Obviously it is going to be negative because we are talking about discounts or decrease. Okay, so the overall change done here will be 36%, and which is not 40% and not at all more than 40%. Okay, so in case of decrease, what happens when we decrease a number by a certain percent successively? We can say that the overall successive percentage decrease is always less than the linear percentage decrease. Okay, now these questions will come in really handy. This concept will come in really handy when you are attempting questions of profit and loss. Okay, and there are a lot of instances where the question talks about successive discounts. There might be questions like what is one single discount equivalent to couple of successive discounts given there. So in all those questions, this concept helps a lot to evaluate and to obviously reject the incorrect choice. Okay, now when we talk about successive percentage change, we just saw it in terms of increase as well as in terms of decrease. So the question arises that whether we always have to take an example of 100 and then see what will be the overall percentage change. No, it is absolutely not. So how do we calculate successive percentage change? Successive percentage change is given by x plus y plus xy upon 100. Now this is a very simple formula to remember. X plus y plus xy upon 100, that is product of the two changes. Now what are x and y? X is the first percentage change made and y is the second percentage change made. Okay, now a lot of people, a lot of you might be thinking ki what will happen if there are more than two changes. I'll come to that point a little bit later. First let's try to solve it with this formula. So I increase the number twice successively with 10%. What will be the result? 10 plus 10. The first percentage change is 10. Second is also 10. The product of 2 upon 100, that is nothing but 21%. Okay. Next, I reduced it by 20%. So minus sign will come into play. Obviously, the first change is minus 20. Next is minus 20. Minus into minus becomes positive. Product 400 and the result is overall result is what? 36%, with obviously a negative sign which shows that the overall percentage change is a decrease. Okay, now what happens when there are more than two changes? Okay, a lot of people refer to various other formulas given here. There is one form of interpretation, or extended version of this formula. Let me quote it in front of you. The formula is x plus y plus z plus xy upon 100 plus yz upon 100 plus xz upon 100 plus xyz upon 10,000. Okay, now think about it, whether you will feel comfortable using this formula in the exam. Okay, it is a lengthy formula. You will put up values, you will calculate a lot of things, and then obviously it is going to take a little bit longer to calculate. Okay, right. So how to solve when there are more than two successive percentage changes? Let's say I asked you to increase a number by 10%, but not 2 times, 3 times. Okay, what happens is, see, let's take an example again. Let's say the number is 100. I increase this by 10%. The result will be what? 110. I again increased it by 10%. The result will be 121. The second percentage change is done on 110. So the base is changing. Okay. If I increase it once more by 10%, the result I'll get is 133.1. That is, I'm increasing 10% of 121. That is 12.1. Okay, so the overall change witnessed here is what? 33.1%. We can see from 100 to 33.1, the overall change will be 33.1%. Now take a pause and think about it a little differently. Can I say that the first two changes can be clubbed and the overall change done in the first two instances will be 21%? What have I done? I've simply used successive for the first two, and we can see 100 to 121, the overall change is 21%, right? So I can reduce it in a certain way where I say that 100 is first increased by 21%, result is 121, and then 121 is further increased by 10% and the result is 33.1, right? So what will be the overall change? The overall change will be 33.1%. Now, what have we done here? Actually, when I was asked to increase a number by 10% 3 times successively, I used the same formula, x plus y plus xy upon 100 for the first two changes, and then the result, I will use that result with the third percentage change again in the same formula, that is 21 plus 10 plus 210 upon 100, and the overall result will be 33.1%. Okay, let me explain this with another example. Say suppose we have 3 percentage changes, 10%, 20% and 10%. So I have to increase a number first by 10, then by 20 and then by 10%. Okay, I use these two in successive. 10 plus 20, the product is 200 upon 100, the overall change is 32%. So what I said, I'll use the result with the third percentage change in the same formula to get the overall result, which is nothing but 45.2. How? 32 plus 10 makes it 42. 42 plus 3.2, that is 32 into 10, 320 by 100 makes it 3.2. That overall result will be 45.2%. Okay, now one more thing. Using this, absolutely okay. Remembering the formula, cool, no issues there. But one question again arises here, that is, does the order of these percentage changes or the order in which we use these figures in the formula, does it matter? So the answer is no, absolutely not. It does not matter. Okay. Let's take the same example. Say suppose we have to increase a certain number successively by 10%, 20% and 10%. Okay, now what I will do here is I'll shuffle these and see whether the overall result is it different or is it same. So what I did, I just shuffled these percentage changes and like 10%, 10% and then 20%. Now some of you might feel that it will change because 20 हम उसको बाद में use करेंगे, but the answer is no, it will not change. See, I use successive for the first two percentage changes, that is 10 and 10. So the result will be 21%. And then I will use this result 21% with 20%. That is 21 plus 20 plus 420 by 100. You can see the overall result is still the same. That is 45.2%. So moral of the story, the order is irrelevant. Okay. Now, guys, this very concept can very well be used in a lot of topics like profit, loss and discount. We just took an example of discounts, multiple discounts being given. Okay, in compound interest as well. Okay, which a lot of people fear because there is this big formula of calculating compound interest, and the general thought process is that when we try to solve questions based on compound interest, they tend to get a little lengthy and very calculative. Okay, so stay tuned for the upcoming videos wherein we will be learning about the usage of this successive percentage change and a lot of examples based on discounts, compound interest and various other forms where this concept can be used.